let's discuss the class organization, which is the most important thing, because this is the relevant aspect of the class. In like the class is organized using challenge-based learning. So the idea is that in this day and age, what is relevant for me is that you guys acquire a certain set of skills that go beyond doing homework and writing midterms. And this is how we're trying to adapt to what we believe is a teaching pedagogy which is relevant for you guys. So today we focus mostly on this. The technical content of the course, I think it's pretty straightforward. We are going to spend some time on it in the next hour, maybe. But the class organization, it's really what you should know in order to decide whether you want to take the class or not. So the idea is that you want to center the teaching on the student, and you want the student to leverage to focus on a certain set of skill to improve their own ability to engage with the material. So the most important thing is collaboration. So you guys will work in group, and this is a skill that many of the students in your cohort don't particularly have developed yet, which is the ability to work in teams. Usually, you guys, when you take classes, you all work by yourself, you do homework by yourself, you study by yourself, and actually, the professor values, the professor gives you a score based on your own individual work, which of course is there to measure your ability as a student and try to measure your learning performance. But it's not particularly useful because when you go to work, there are very few people that can do a work where they work by themselves without interacting with others, right? So most students will have to learn how to work in teams when they enter their working life, and this is not particularly efficient, right? It would be more useful for you guys to learn to cooperate as soon as possible so that you become more effective, because working in groups it's a very complicated skill to acquire. The important thing that we will focus on is self-learning. So when I will teach, I will try to keep the frontal teaching to a minimum. So I think this class is going to be the class in which I will talk the most, because from now on, I will try to limit my teaching to, let's say, 1 hour, 40 minutes per week. I do not think it's very useful for you to just listen to me ramble on and on about what I think is important. So I will give you all the material to learn things. I will give you all the keywords and the correct references and the links, and then I will expect that you guys go and explore the material by yourself. Another very important part of the course is using of AI tools. Of course, you guys already started a couple of years ago, probably, to use ChatGPT, Grok, whatever. These Gen AI tools very extensively. So I think that for this course you will rely on these tools even more, meaning that we encourage you guys to go and ask questions to these Gen AI tools, to this chatbot, and this is actually an integral part of the course, right? So there is Python in the title of the course, but we will not spend 1 second on Python. I will not tell you how to call a function, what are the input of a function, what is the expected output of the function, because of course you will install Visual Studio, and then you will just ask your Copilot how to program, right? It is completely inefficient for me to spend time on teaching you how to use Python functions or even the Python script constraints, right? So in the previous versions of the class, we will have maybe a couple of hours in which we give the basics of Python to students, but we decided to remove this class because it's no longer needed, right? So Copilot will tell you exactly how to fix the indentation in Python, what are the expected input and output of a function, how to write a for loop. So even this, let's say, more syntactic aspect of the programming language are no longer relevant. So we have to live with the times, right? The other thing is that most of the class, since there will be no frontal teaching, it will be you guys presenting your work. So that will take probably 80%, 70%, 70% of the class. So you guys will be presenting in team the work that you did, and then you will get the chance to practice your communication skills as well. And this is something else that it's a skill that you guys probably haven't developed yet, because when you take most of your classes, you just shut up in class and you don't use your verbal communication at all when you're in class. Actually, you're discouraged in using your verbal. So make sure that I will make sure that you guys talk as much as possible during my class. And then, especially in the final project, we will always reward creativity. So if your solution relies on a creative solution, if the solution to the challenge is creative and relies on some creative idea, we will always reward the creativity. And in fact, the scores that I will give, usually that will be just looking at the creativity, right? So how many lines of codes you wrote will not be the relevant aspect. The relevant aspect is what is your deep understanding of the problem, and can you find the creative solution to the problem? Okay, so let's describe how the course will run. So the class logistics are kind of complicated because this is you will see in a second why the class logistics are complicated. Mean that there are many different elements of the class that need to come together. So we spend time in the last 2 years to describe the document of the class logistics in this online in this document. So if you have any questions before you ask me about this specific detail, go check the document. Do a Control F and try to find the part of the document that describes your question. But let's go through some of the elements here of the course. So the course is based in challenges, meaning that every 2 weeks we will form a group between 4, 5, 6 people, depending on the number of students in the class, and you will be assigned a challenge. Okay. So when we assign the challenge during the class, I will take some time to explain the challenge in broad terms. Then you guys will form groups, and you will work for the challenge for the first week. And then during the class of the first week, I will check with each of the teams what's the process of solving the challenge. How are you guys doing? Is there any problem? Is everybody contributing? Do you have any questions for me? Is there any uncertainty in the way the challenge is formulated? And then after the second week, then you will present your challenge, and then we'll repeat this between 5 and 6 times, depending on the calendar. Then the challenges are reviewed by the other students. So once the challenge is completed, we will ask you guys to submit a report, the code repository, and a video in which you present the class, in which you present the challenge, and you will also present the challenge in class. And you will distribute this submission to the other team members, and each of the person in the class will be tasked with scoring the material submitted by a certain team. Okay, so at the end of the process, there will be the material submitted by one of the teams, and we will have all the reviews submitted by the other students, my own review of the material, and we will take the average of this, and this will be the grade that you have. Then the last part of the course will be a final challenge, and the final challenge we will give you 4 weeks instead of 2, and we will review the material multiple times, and the last challenge will be more focused on creativity, and it will count for a large portion, the biggest portion of your grade. So the group formation has 3 phases, because I want to make sure that everybody works with everybody else, and you guys have the opportunity to talk to each other. So since the class is going to be fully online, and we are just going to meet each other online, it's a pity that you guys will not have the chance to interact in person. So to facilitate the process of students interacting with each other. And we will have a first phase in which we will randomize the group formation. Okay, so this will be done as follows. We will ask some of the class members, maybe next week, at the end of next week, we will ask some of the class members to be group leaders. Okay, so we're going to identify 4 to 5 group leaders, and we will announce these group leaders somewhere, and then we will randomly assign students to group leaders, and you will perform the challenge with a set of students that most likely you don't know. And this, of course, it's gonna be very challenging because you guys don't know each other. Students usually they are not particularly good at communicating, and they don't communicate very proactively. So it's going to be a little bit of a struggle for everybody to sort of learn how to quickly synchronize with other people. Again, it's a skill which is very important in real life, and you guys don't get to practice too much in your university years. And our expectation is that we will do 2 to 3 to 4 challenges in this way, depending on the size of the class, until we are sure that there is a good rotation and everybody knows each other. After that, which should be around the midterm week period, then we will let everybody form the groups that they want. So we will ask you to form groups independently, and then work with the people that you have chosen to work with for the second part of the class. And then, of course, there is the third part, which is the final project. In the final project, you can work with whoever you want. Good. So why do we have these 3 phases? In the first phase, the objective is to let people meet each other and talk to each other, and you decide how you want to interact with each other. And we will also have a rating of the students performed by the other members of the team. This is something else which is very crucial, because you guys have to learn how to communicate earnestly with each other and how to provide earnest feedback about each other's performance. So we will see later, but you will be some more details, but you will be asked to grade the commitment of the other students and the performance of the other students, so that by the time we get to the midterm week, we will have a certain profile of our students, right? And when people form groups for the second part of the course, my expectation is that you will try to choose the people that have interest and capabilities which are complementary to the one in the group, in the remainder of the group. So because in phase 2, you will really have to be strategic, in my mind at least. You will really have to be strategic in the way in which you choose your team members, so that you have somebody that programs well, you have a good leader, you have somebody that can express themselves so well during the class presentations. And this is my expectation, right? So in phase 1, everybody has the chance to meet each other and to interact with each other and have some one-to-one experience with each other. And then we will understand something about your commitment to the class, your capabilities in terms of programming rather than communication. And then in phase 2, you will try to collect some group members that are particularly effective in completing a challenge. And the expectation is that you will be strategic and pick complementary capabilities. Of course, what happens most of the times is that people in the same room end up forming a group, or people that know each other already form a group. But I cannot stop you guys from picking your favorites in a way which is not optimal from an engineering perspective. Okay, and then the final project, of course, you should have completely owned your group dynamics, and you should be able to achieve the highest efficiency in addressing the challenge. Very good. So the evaluation of the challenges, we said, will be student-led mostly. So I will give grades always, and but my grade will contribute to the challenge grade as the grade from the rest of the students. As we said, phase 1, you will be asked to grade both your team members and the work of the other team. So this is what we call the intra-team evaluation and the cross-team evaluation. And in the cross-team evaluation, we will see if there was any particular problem in communication and somebody stopped working on a certain challenge. Yeah. So the grade that you will receive in the first phase will depend on the intra-team evaluation. And in phase 2, you guys would have chosen how to form the group independently, so you will not be assigned randomly. So having removed the randomness and having introduced free will means that the grade of the team will be the grade of each single individual. Okay, so you will have a team grade, and the team grade will be the personal grade. In phase 1, the team grade will be dependent on both the intra-team evaluation and the cross-team evaluation, but in phase 2, it just depends on the cross-team evaluation. Everybody will get the same grade because you decided to be in the same group. So if you end up in a group that doesn't work well, so you don't perform well and you get a poor grade, then this is reflected on every member of the group. But the opposite is also true. So if you guys work wonderfully together, then everybody will get an excellent grade. So in this sense, the class is nice because it doesn't penalize, there is no ranking of the students, right? Everybody can get a good grade if you guys work well together. So in the intra-team evaluation, we will try to scope out a little bit the capabilities of each single student. And we will ask you to rank each of the team members in 3 categories, which is leadership, theoretical approach, and action-oriented capabilities. So if you're a leader, then you have strong organizational skills and motivation skills, and you are the leader of coordination. Okay, so you lead coordination in certain tasks. If you are a thinker, it means that you are focused more on creativity and finding the innovative solution to the challenge. And if you're a doer, it means that you're more task-oriented, means that you're the coder, means that you're the one who sits down and starts writing the code. So we will ask you to give a grade of each of the team members over these 3 dimensions so that we can sort of have this description of the students based on these three dimensions. Of course, this doesn't completely exhaust the dimension in which the students can differ from each other, but for the purpose of this class, this is how we try to cluster the student capabilities. Very good. So the cross-team evaluation means that you will evaluate the output of a certain team to a certain challenge. So this will be a written report, a video report, and the code base. So the written report usually is the slides that the student present in class. The video report, the student just record themselves presenting the video. And the code base, of course, is the code that was implementing the challenge. The thing to notice here is that in the video report, you will be asked, all of you, to talk. So you will have to record yourself presenting part of the solution to the challenge. And this is very important for me because the ability of speak clearly and convey his idea clearly, this public presentation, is something that you guys don't get to usually practice in your university life, but it's, of course, it's of crucial importance, right? So when you will have a job, as I hope all of you will have to interact daily, and the ability to communicate clearly using technical English with a clear tone, with the correct speed. It's very incredibly important. And of course, if we didn't do this class online, then this will not be possible, because if we have 3 hours of class and we have 50 students, means that everybody could talk only 5 minutes in the most efficient way, let's say. But of course, since this is a video recorded, then we can give the video to all the students in the class, and it becomes much more feasible for everybody to practice their oral communication. Good. So the way in which the grading will work in the class generally is what we call overranking. And this is because we are looking for ranking policies that will achieve the following. You have to be forced to give a ranking to let's say either to a team member or to a team, and this is because you guys have to be. We wanted to avoid the case in which you give, let's say, a grade of 10 to everybody. Okay, So there is no equal grades, right? You're forced to rank something, so you have to decide what relatively, right? What is among two submissions, which submission is better than the other. But still, we want also to force you to be able to express a difference, differences in the grade, right? So if you get a grade of 4, if you get a grade of 8, of 10, it's clear that the people that got the grade 10, they did more than twice the people that got a grade 4. So we also maintain a scale. And also we want that the grade of each team is not affected by the total number of grades that are present in the scale. So we came up with this overranking system, which works as follows. You're given numbers between 0 and 10. You can give, let's say, 3 entries. You have to give a grade to each of the 3 entries, and grade are repeated, so that then when you average across multiple submissions, let's say among multiple team members, what do is that you sum the score that each team member receives across the ranking, and then you normalize over the maximum total ranking so that everybody gets this grade. Don't worry about this. It's not really relevant. The point that you should remember is that there is no penalty in giving high grades. It's as follows, right? So if you give high grades to everybody, let's say that you give 10, 9, and 8, is the same as giving 8, 7, and 6. Okay. So what matters is sort of the relative ranking of everybody. Good. Now the final score is as follows. So phase 1 we counts only for 25% of the final grade. This is because phase 1 it's very tough, because the students are coming and leaving. Some students will stop working because they will drop the class eventually. You are teamed with some random people that you don't necessarily know. Some of them are going to be good, some of them are going to be bad. I wish you all the best, but on average, right, if we give an average, and then you have half of the students are going to be above average and half of the students are going to be below average in their performance in the team. So since it's very tough, it's I don't want you guys to worry too much about the quality of the submission at this phase. So we'll just give it 25%. Then phase 2, 35%, and the final challenge will be 40%. So as I said, the final challenge is where you guys are have the chance to choose your team members, and that's where you're going to be more creative and you're going to have the most time. So it seems reasonable that we give this the largest part of the grade, so that hopefully you guys can get a grade that reflects how much you learned in the class. Yeah. So as I said, if in phase 1, the message for this slide is as follows. If in phase 1 you end up with a set of students that are not responsive, and some students will participate to the challenge, and you're left working too much, I don't want you to be stressed. This is not going to count too much toward your final grade. So even if you have a couple of bad experiences with team members in the first phase, you're still going to get 100. There's no problem. Good. So if there is any question, you guys let me know. Otherwise, we go to some of the usual questions that we receive. Let me know if you have any questions so far. As I said, this is very partial. Any questions so far? As I said, was saying, so this is a partial description of the class. There is a document that describes all things in more detail. So if you have any pressing questions, let me know now. Otherwise, I'll proceed. Okay. So question. Why don't you, so as I said, so there is Python in the title of the class, but of course we will spend absolutely zero time teaching you Python. And the question is, and you know, as a student, you might ask yourself why we don't do this. I addressed this already partially. The point is that Python is a very high level language. So programming in Python doesn't have the same feeling as C++ or Java, right? There is no idea of efficiency, for example, as such. So if you are in C, then you have this sort of economy of variables that you have to create because you have the space in mind. You have pointers, and if you do some tricky playing around with the pointers, then you can save some megabyte of space in the memory. But this is not relevant in Python, right? Python has functions that are very high-level function. You can call a function that does some very complicated operation that resides in the library that has millions of lines of codes, and for you this is just a command, right? And that's because it's a very high-level programming language. So the way you use this programming language is toward end goals. It's not some basic operation that you have to learn. You want to do PCA, there is one line in Python. You're not expected to go and write matrix decomposition and then write all the program from matrix decomposition to PCA, right? So that's part of the reason. The other aspect is that the documentation is limitless. So there are many courses and videos and YouTube tutorials and and notebooks. So no point for me to spend time teaching something that someone else could teach you better. Okay. So I'm sure that if you want to learn how to use loops in Python, you can go online and find a perfect YouTube channel with a person that uses Python every day for 20 years and he knows better than me. So no point for me to waste time there. And then ultimately, I don't know if you guys have already experienced it, but there is this beautiful thing which is called Copilot, which is a beautiful and terrible thing. And if you don't understand the code, so first when you write the code, you ask Copilot. If you don't understand what Copilot does, then you ask ChatGPT. So let me ask you in chat, have you used Copilot yet? 0/1. Please answer in chat, guys. Right? There's only one lonely guy that didn't use Python yet. Yeah, I didn't use a Copilot yet, so I pity this only single zero in the chat. Yeah. So of course, this is the point. Oh, two people that didn't use, 3. Wow. Anyway, so when you start using Copilot, okay, so because you guys are young, so maybe you didn't do much programming before Copilot came out. But for people like me that studied programming for maybe 20 years and consider themselves programmers to a certain extent, okay, not daily programmers, not professional programmers, not experienced programmers, but proficient programmers. When Copilot came out and we had to reassess what coding was for us and how we had to be efficient and when we code, it was a big change in perspective. Okay, it's really a transformative tool, and how this tool will improve and affect software engineering in the next 5 years, I think nobody can envision it. And so companies are investing trillions of dollars on Copilot and similar tools for software engineering. So it's something that makes you wonder what programming will be in 5 years, right? So at the moment, Copilot still makes the code that Copilot writes isn't particularly good code, isn't particularly efficient code, but it's very fast. And it allows you to cover a lot of ground quickly. So as I said, I would not. So when you use, let me say this: when you use Copilot, depending on for basic tasks, it's fantastic. When you get to medium tasks, then you cannot rely on what Copilot will produce for you. And so I would like, part of me would like to warn you against relying so heavily on Copilot, when you go past a certain basic level of programming. The other part of me knows that by the time you will go and have to use this tool professionally, the capabilities of the tool would have increased twofold, threefold, fourfold, depending on how long it takes you to graduate, but also depending on the evolution of the technology. That I don't want to prevent you from trusting this tool completely. So let me say it this way. If you use Copilot to write your code and you do not understand what Copilot does, I will not. Okay, there are no two ways about it. I can still very clearly tell when the code performs what the student wanted the code to perform and when this is not the case. And this is because the challenges that I will give you, they will require an understanding of the code, which goes beyond what Copilot can do at the moment. Okay. Having said this, it is probably the fastest way for you to address this challenge is to use this tool. And once the tool has done what the tool has done, then you will have to sit down and try to understand what's the logic behind it. And if you try to blindly use it, then of course you will lose a learning opportunity. That's clear. But it will be clear also to us that that you lost this learning opportunities. Okay. So this is a very complicated discussion. I don't want to spend too much time on this. Just try to have an experience in which you use this tool, you understand its limitation, so that you know you have the maturity to know when you can rely on the tool and when you should doubt it. Okay, good. And for the two people that didn't use it, go home, you install a Visual Studio, and then after you install Visual Studio, you install Copilot. It's already going to be there. And yeah, and then you tell me when you come back to class, how did you sleep the first night that you saw Copilot writing code at the speed that it does? Okay, so the other thing is that we're going to use Slack to communicate. So as I see that we have few people in Slack, let me just check quickly how many people we have in Slack. We have 22 people in Slack, but we have 34 people here, so some people might not be interested in the class and they're just checking the class and they will join later. I think a couple of people were not able to join Slack. So I will do this. I will take So if you think about this, so Slack is a platform for team management and for co-working. It is basically very similar to Discord, and I believe that all of you use Discord. Slack, unfortunately, is a paid tool at some point, so it is not completely free. I am happy to have this paid tool because, you know, having free tools means that you are producing information for someone, and then the information that you produce will be sold. So I'm not against paying for software. I understand that Discord is free and you guys use Discord because it's free. We also want to use this tool because we believe that it's very efficient for you to use this tool to work together. We think there is a value in having a dedicated online space for you guys to cooperate. In my experience, 50% of the students end up using Slack talking inside the group. The other 50% will end up using Line. Some people use Discord. Very few people use Google Chat. If you don't like to use Slack, that's perfectly okay. Just remember to turn on some notifications so that if we post something on Slack and we don't post on E3, then you can still get the notification. We also have a calendar event if you want to add the class to your calendar. And what else? We have a calendar event. There is an AI tool that records the conversation. So if you accept the calendar event, then after the meeting, you will receive an email from the AI tool that will summarize the meeting. So if you want to have the transcript so that you can ask questions to the AI tool, you can do that as well. So this is the Stefano author note taker is there. This is, for example, if you want to follow this, we can share this. Let me check what is this, the setting of the link, just a second. So I can post on Slack directly. Just a second, copy link, more options, should be this. Yeah, so this one here should be the link to the author AI tool, like taking notes. No, not this, copy link. Okay, so this is the author AI tool. Oof. Sorry, guys, wrong shortcut. I hopped out. So, so if you accept the calendar event, then you will be able to receive the AI tool notes. If you don't receive the AI tool notes, you let me know and I'll send you the link. So basically, what I'm trying to say is that the digital fingerprint of the class are very large. So you're gonna have the videos, you're gonna have the transcript, you're gonna have the author AI notes. You're gonna have the slides, so everything should be there. So yeah, so see if you like it, and if you don't want to attend class, of course you don't need to attend class. Just if you're supposed to present in class, let your teammates member know that you will not attend, but otherwise this is it. Okay, so come back to the slide. We use Slack for this reason. If you don't want it, no problem. Just remember that sometimes we will just post on Slack because it's more convenient for us. And if we forget to post on E3, it will be better for you to have notification of the post on Slack. And because usually I use I address everybody, so you should receive a notification that you were mentioned in a post if I do that. Okay. Do you use Discord often? Let's see, 0/1. Let's see how many people use Discord. Yeah, of course. I know. Yeah, so from next year, maybe we will switch to Discord. I know that it's more convenient for most people. It's just that I don't want to be in the same platform on which you guys talk about video games with your friends. Nothing wrong about it, right? But just I would like to be in a different digital space so you don't get confused and you don't send me screenshot of your latest video game escapades. Okay, good. Okay, let's go on. Let's go with this. So as I said, if you don't want to attend in person, no problem. Okay. So sometimes people complain that the material that is covered on the channel, the material that is covered in the challenge is not a material that I present in class. Okay. So usually the challenge is much harder material than the one that I present in class. And this is the objective, okay? So these are challenges and they are not homework. So you're not supposed to already have the knowledge which is necessary to address the challenge. And as we said, self-learning is one of the objectives of the class. So there is the strong expectation from our side that you will go and you will try to find the material which is relevant for the challenge. Sometimes also to this material, you will find a limit, right? So you will be able to find maybe 70% of the material that you need to complete the challenge, and then you will have to go and fill up the rest of the 30%, basically what is a research output, right? So you will have to go and dig as deep as necessary. And the other aspect is that the material, the distance between the material that we provide in class and the material that you need to solve the challenge is also measured in a way in which you will need to work in teams to accomplish it. If we give you something that you can solve by yourself, then there is no need for you to work in groups, right? So the amount of extra material needed to be covered in order to complete the challenge accounts for the fact that you guys need to organize yourself, and you need to tell, oh, you go and you look for the code to accomplish this. You go and you look for the paper that does this. You look at the YouTube channel from that researcher that was presented at the conference. So this is all part of the design of the class, right? So you have to be strategic in the way you address the challenge. You cannot do things unplanned. So some people they struggle with the English pronunciation or with the English accent, or you guys. Unfortunately, when you guys take classes in English, they're usually from a Taiwanese person that has a very Taiwanese accent when they speak in English. So that's sometimes a problem for somebody. And also sometimes if I'm not too focused, I start speaking very quickly. So let me know if I speak too quickly. And you have caption on the video. The captions are usually really good. My calendar is usually pretty full, so when I speak, I always take into account that I have to speak to. I have to convey as much as possible. So sometimes I speak too quickly. So please to bear in mind. And if I speak too quickly, let me know. The other big question is that people complain with us all the times, from day one to the last day of class, that they have difficulty with their teammates. So this is something that you will experience for sure. And in phase one, it's going to be very severe, right? In phase one, you will. It's usually the worst case because some of the team members they decide to leave the class, and unfortunately, it is allowed to leave the class up to the. I don't remember, but people can drop the class up to the midterm without getting a bad mark on the transcript, and so. This is a way, I understand why in some other classes this is allowed, but for this class, it's very deleterious. So it is very disrupting for me. The student can decide to drop the class and do not participate to the challenges. So please, if you take the class, know that you need to be committed to work every week toward the challenge. And but some other issue with this comment is that you guys generally do not have the ability to work in teams. That's not fully your responsibility, because many of you just focus on classwork for your whole life, and so you just didn't develop what are the skills necessary to work in teams. The class is also there to give you this experience of working in teams. I just want to say that it's a very difficult task. And it's something that requires you to be a certain type of person. You have to be proactive. You have to be forthcoming. You have to be committed. So it takes a lot of personal qualities to be a good team member. And I will argue that the qualities that make you a good team member, they make you also a good person. That's just my perspective. So try to be good team members before complaining about others. That's for sure. And also, unfortunately, Taiwanese students, they take too many classes and they are in class until 9 p.m. at night. And so the attitude that they usually have toward class commitments is to try to do everything at the last moment and to just try to burst through the material as fast as possible. Of course, this is not good for you, because when you work fast, you also forget fast. You for sure have the personal experience that the material that you remember the most is the material on which you spend the most time. But yeah, apart from this, I don't have any other comments. So try to be a good team member. Don't leave your teammates unread. And I think that sometimes the students think that it's cool, that you just pick it up and you do something at the last moment. And it's like, oh, it feels like you're a superhero because you're able to do things so quickly. You're not like the other people that need to study something for a week. You're a half genius and you can do it in 2 hours. But of course, that's not the case, in the sense that the issue is retaining the material, right? The issue is that you study something and you understand it in a way in which it becomes part of your personal knowledge, and you can internalize what is the deep meaning of the concept that you see in class. For example, there is we're going to study clustering, right? So there is a sort of data. You have some techniques that allow you to separate the data based on the features that they have, and the math behind it has something to do with projections. So if you study quickly, then you go through the material and you're able to complete the challenge, whatever. But understanding this idea that data lives in some lower dimensional subspace in which fewer dimensions are as expressive as a larger number of dimensions. The distance between samples can be represented in a higher dimension or in a lower dimension. And you can approximate the relationship on lower dimensional subspaces. These are concepts which are useful to have, and it takes time to internalize, and they're useful for you in the long run. So try to be timely and to work in a timely manner also because of this, right? Good. Then another thing that happens is that you end up in, this happens very, very rarely, but I want to put it out there. Sometimes nobody in the class is responding. 1 week passed, you're the only one that is working. You send out emails, an emails reminder to everybody. You send out line messages, you send out Slack messages, you send out pigeons, you send out smoke signals, and nobody's answering. And you get frustrated. In that case, talk to the TA. The TAs are there to help you. The TAs knows the psychological struggles of people. And generally, the TA will just merge with some other group, and that will give a 0 to the other team members. Okay? So we are not here to punish anybody. We don't want anybody to fail the class or to receive a bad grade. But basically, we just want to make sure that everybody has a good experience. And as we said, you go through these spaces, right? Working in teams, self-learning, communication, digital fluency. And so we just want you guys to work effectively, to not waste your time, right? So if you're stuck and nobody's working, just let TA know. They will put you in some other team. This is going to be the best team of your life. You will be welcome with open arms. You will make life friends. You will find the life partners. You will find you'll find the best employee. Anyway, you're gonna have a great experience. Okay. So if you're in a slump, you don't have good team members, let the TA know. They will do whatever necessary to make it best for you. Okay. So this was 1 hour of me rambling on and on. So let me know if you have any questions. Oh, okay, so somebody's asking. So ask questions here if you have. Ask questions here. Let me show you the challenges from the previous years. So I'll stop sharing and then go to my beautiful YouTube channel with hundreds of thousands of subscribers. Yeah, subscribe, yeah. And let me pull up some playlist. Okay. Yeah, so if you come to this page, so this is the data science team. Okay, and this is the okay, so this is the playlist from this is deep learning. So this is one of the playlists. For this should be data science, right? Let me check. For machine learning data science, that's 10 videos. Let's see, there is one. There is another one. There should be. Let me find out just a second, guys. Let me find the. Anyway, so the playlists are here. So if you go, this is my YouTube channel, so you find everything there. I just have to pull out. Yeah. But anyway, so the videos are all. They're all online. I'm just trying to find the one from last year. But basically, yeah, so some of the challenges are there. Then let me also give you some of the challenges. Just a link to a challenge. Let me just give you an example from last semester. There was a machine learning class, right? So PDL, Python for Deep Learning, is the class from last year. And so this is something, this is an example, right? So just a second. What is the share? And you can view this project. So like this. Okay, good. Okay. So if you look around the YouTube channel, you will see the other all the other recordings, right? And I post the link to Overleaf, where there is the challenge from deep learning from the class from last time. Yeah. Okay, let me ask any other question, guys? Let me also post this set of slides that we are following now. Any other question, guys? So I think we're going to take a little break. Let me just ask you a couple of questions, then we take a 5-minute break so you guys walk around. Have you taken some of my classes before? 0 stretch 1. I can tell already there are a bunch of exchange students. No, guys, you don't know what you missed. Very disappointed. Very disappointed. Nobody has taken my class before. Because some people take, so as I said, I do 2 classes. One is the Python for deep learning. The other one is the Python for machine learning. So the machine learning is the first semester and the deep learning is the second semester. But I think usually there are a bunch of students that only take the deep learning class because there are more mandatory classes on the first semester. And you have more space for elective in the second semester. Okay, very good. So before we take a break, of course, if you want to meet in person, I'm always in my office, ED 716A, so Engineering Building 4. You come to the 7th floor, and then you look for the bikes. There are always like 15 bikes outside of my office. Fortunately or unfortunately, I'm not sure. What else? Yeah, anything else, guys? Yeah, if you want to talk, you just send me a request. I'll send you my calendar. You pick a time in my calendar and we talk. Yeah. 4. What is 4? Somebody answer 4. Have you taken 4 of my classes? No. Hey, somebody took one of my classes before. Oh, okay. Oh, so which class did you take from me? You took the deep learning one? Yeah, good. So you're a returning customer. Very good. Very good. I hope you guys got a good grade, right? I think you guys must have done well. So, no, it'd be fun if you take the class and get a good grade. So also happens that some of the students take this class, then they have to drop it midway because, as I said, there are a lot of mandatory classes for students in the first semester. And, then there is the usual electromagnetic or signal system, and you get a bad grade. And so in order to make up the grade for the class, you drop this class, and then you come back the next year to take it again, or you take the deep learning one. Yeah. So I don't particularly like. I don't. If you have to drop the class, or if you didn't take the, or if you decide not to take the class, that's not something that speaks. I hope it's not something that speaks better about my teaching. But I understand that some other classes are more focused on knowledge and measuring your knowledge and measuring your learning. Personally, I don't find it very compelling or very useful for you guys. That's my opinion. So I'm gonna start begging for leaders. I think if we are around 30 people, we need probably 6 leaders, right? So next, either this week over Slack, or next week around class, I will ask if you want to be a leader. Usually we give a leader a bonus. I think is a 10% increase in the grade if you are a leader, because usually the leaders have to work more because they have to send emails to everybody, have to synchronize. So usually we give a bonus to the grade of the leaders. And I think it's 10. Yeah, Guide is 10%, right? The bonus to the leader should be 10%. Guide is 10%, right? The leader bonus. Okay. Yeah, 10% grade improvement to the bonus. 10% improvement on the grade for the leader. And okay, so let's take a 5 minutes for the break, and then I'll give you. Yeah, let's take a 5 minutes break now, and then when you guys come back, we discuss a little bit more. So yeah, so let's come back at 14:33. I see you back here. Drink water, walk around. I'll see you back here, okay? 5 minutes. Okay, guys, let's see what we can do today. So let me just tell you, in case you didn't read the email or something. So the material is all here, okay? So this is all the material that we will cover. Just notice that, of course, this is a Harvard course. Why spending time preparing material when people in this course, they did an excellent job for the past 10 years, probably. So notice that in the URL, right, you can move, this is year 2021, you can move to year 2022. There is, no, I think they privated some of the material. Anyway, so the 2021 course is still there. So usually I use the 2021. They have, so the course is, the material is pretty there. It's a very fundamental class. So these are the previous one. What to say? So it's very standard class. So the material is it's very classical. Don't worry about the material itself. Of course, since it's machine learning, there is material everywhere, so you can just use Google and you will find all the relevant material. And as I said, it's not particularly compelling to use this slide rather than others. If you prefer some other class, go ahead. Then what can we discuss? We could let me give you two options. Option one. We do some ML background. Option two. Let's say that will take us 30 minutes. Option two. Some more reflection on academics in the after LLMs. Let's say 15 minutes. Okay, both guys. Tell me what you want. Really? Okay, we have 2, 2, and 1, 1. I don't know if it's because shorter time or it's because you like the topic. Go ahead, guys. Go ahead. Let's see people. 1, 2, 3, 4 versus 1, 2, 1, 2, 3, 4. Okay, let's do a compromise. Since it's 50-50 roughly. Let's do 15 minutes, option 2. Then we do 15 minutes of option 1, and then we start over next time from the rest of the background material. Okay? I think this is the best thing to. Okay, so let's just discuss this briefly. Okay, good. I think it should be. Is it the same presentation slide set? Okay, no, I think it's this presentation slide. Good. So yeah. So why are we doing this? Right? Why don't we keep teaching classes with exams and homework and so on, right? So we are in a new era, right? So in November, already 3 years ago, ChatGPT arrived. And then there was as we said, right, trillions of investment in AI technology, right? So language learning has been revolutionized. Law practice has been revolutionized. Healthcare has been revolutionized. Then we came to the image generation, video generation, music generation, voice cloning, right? So now generative AI is also used for voice cloning. So you can have the president of the United States giving you a phone call and sounding perfectly real to you. 3D animation, right? So also 3D assets. And if you have followed the news, right, you've seen that there has been a lot of news regarding software engineering, right? So all the CEO, the software engineering companies, they say that they will get rid of the software engineers that want to use AI. The Microsoft and Meta, they keep firing people, right? Amazon, they keep firing people because there is this expectation that generative AI tools will be used for replacing entry-level engineers, entry-level software engineers. And so already the unemployment rate between entry-level software engineers is very, very high. It's because of course the reasons why this happens, they are not fully clear. And we don't know how much is hubris and how much is actually a sound economical decision. But basically, lots of uncertainty in the industry, in the software engineering industry. The other big shakeup has been, for example, in creative industries, right? So I don't know if you have followed, but basically part of the strikes that were in 2023 in Hollywood was because writers were being replaced by AI. Music industry is in complete disarray because if you go to Spotify, now there is probably a 50-50 chance that the music that you listen to it's produced by AI, and so there's somebody that generated some few million songs, and now they're collecting royalties of this. I think it was the news a couple of weeks ago that there was an artist on the Spotify most listened that it was AI generated. Voice actors, they are losing their jobs. I think the Amazon announced that they will completely replace voice actors with AIs by the next year, and so it is very clear that there is an intent of replacing human labor with AI labor, and so this will also come, of course, to the academic scenario, right? So me talking to you today could be replaced by generative AI, Stefano. That would probably be a better job with me. It could be personalized to every of you. It could call you by name. It could know what is the previous knowledge that you have. It could come to you at midnight or 4 a.m. So as teachers, we have to face the fact that our job will be eventually at least partially replaced by these tools. The other aspect is that we do not know what type of knowledge we could teach you that will be there in the next 3 to 4 years, let alone for the rest of your career. So think back to the same university maybe 15 years ago. You will come in, they will teach you the FFT, they will teach you how to do a couple of RF circuits, a couple of basic programming, and then you were set for a lifetime in a company, right? You could be an engineer in a company, and you'll be set for life with the knowledge that you acquired here. Now, I think it's very doubtful the concepts that you learn now will be there in the next 5 years, and I can for sure tell you if you study this theorem, right? If you study this algorithm, then you could use this algorithm in 5 years from now, and you will be able to pay for your for the food and rent. But this, and so if you think about how many of you will have an employment, that's also a big question. We don't know what type of jobs will be there, what will be the employment of people in these jobs, and also the skills. It's not clear, right? Because already now you will experience this in this class, and I have experienced it already there. It would be harder to, yeah, your interpersonal communication will be mediated also by these generative tools, because when you talk to somebody, they will use AI to write you an email reply, and when you meet them, they would have prepare, let's say, a set of PPTs, that they prepare a set of presentation slides that they use AI for, and so it is now also not clear what will be the effect of this AI, right, on our social interaction. Think about social media right now. Social media, you cannot rely on anything, right? There is no idea of what you can achieve, or what the posts are done by humans, and so it's very difficult to say for me as a professor to answer these questions. And so we have to be realistic with this. And of course, these tools are not perfect. There are things that you will still appreciate about the human teaching your class, but maybe not so much in the future. And but the thing is that as professors, our job changed along with the technology for a long time, right? So before we had the printing press, people didn't have availability of books, so they needed a professor that read a book 10 years ago about some mathematical concepts, right? And then we got the printing press, and everybody had books, so professor didn't need to memorize books. Then professors were there, for example, to do plots and to do graphs, and you couldn't get that from a book. But then the web came, and then everybody was able to exchange computer notes there. But then the professor was still there to perform the class and be interactive and answer to you. And then the YouTube came and that takeaway. So hopefully there will still be something for us as teacher to do, which cannot be achieved by these Gen AI tools. And yeah, the performance maybe for the next few years, the performance of, let's say, a generative AI teacher will not be the same as I have, because I get better with time, slightly, until I hit, let's say, hopefully 90 years old, and then I'll start becoming terrible. So, but I think that what's really missing, what I can bet on as a tool for you guys, is for sure the connectivity, right? So I know that in order for these tools to accomplish something, right, we still need connectivity among humans to achieve goals, right? So these tools, they are not integrated then with each other, right? So the connectivity is not there. And so the class pedagogy is really focused on coordination and collaboration because of that. Because I believe that the coordination between you guys and your ability to work in teams is going to be something that will remain as a fundamental pedagogy, right? So yeah, the objective is for you to develop what will be the possible shape the work will have in 10 years, right? So maybe in 10 years, people will not work every day. They will just get together when there is the need, right? And they will form a group. They will agree on a goal and the objective to do, decide the roles and responsibility, maybe a contribution, communicate effectively. Maybe this will be the true objective. Okay, so that's why we're trying to challenge-based learning, and yeah, just know that many institutions are trying to implement this challenge-based learning. I think Asia may be the worst place to do this, since Asia has a very Confucian tradition and view of learning. Doesn't matter. Of course, many people do it in different ways. Some people have the challenge is only done by a single person. Somebody has a different duration of the challenge, or maybe different format. But basically, this is my personal choice and what we're trying to develop. And yeah, so I think let's stop here for now. And now let's do just a little bit of good. So we started at 30, now it's 45. Let's do 15 minutes of background on machine learning, and then we move on and we talk to you guys next time. So as I said, so there are some big questions regarding what is the future of academics. I believe that this is a way of teaching class that is still meaningful for me. If you have any personal thoughts, let me know. And if you go to a class where you still need to sit down and to listen to a professor talk, let me know how it feels, because I don't want to go back there ever again. So that's it. Okay, good. So as I said, we'll use this Harvard lecture notes. I don't see any point in producing material, and so this class is a sort of a historical class on computer science from the computer science department. So let's go ahead. So let's go. Let's see what is data science, and what is the data science process as people define it, and let's see some examples. Okay. So this is an old slide, right? So what are the best jobs in America? Of course, data scientists, data engineers, software engineers are still the best paid jobs. And these are the most viable companies to work for are Amazon and Google and Meta. And this has been so the salaries are usually also very high. This again, things are changing at the moment, but the salaries are really good. And I think that's why you guys are here, because it's clear that there has been a substantial jump in capabilities in data science in the past 10 years, and the whole world wants to do machine learning and deep learning. So it makes sense that you guys are here. And there are plenty of memes on the internet. Let's say which one you know. So this is the deep learning meme, right? So I think you guys know. Let's see. I think you know. Let's see which memes you guys know, right? So let me ask you if you know. Do you know second row, second picture, right? The other guys you guys should know, right? I see. Yeah. So this is one of the fathers of data science, and actually, it's a very interesting personal story, I think. Yeah. So a couple of people, we'll discuss it maybe later, but people talk about the winter of AI, right? There have been a couple of winter of AI, which long periods of times in which no progress was taking place in machine learning. And then some people stuck around, and they were able to. Jeffrey Hinton, Jan LeCun, they were there, and they kept working on this topic when nobody believed them. So what is data science, right? So science was only empirical, and people counted stars, right? So that's when data science started. And knowledge was only empirical. People knew which stars didn't move at night and when crops were there. And people created machines to measure this phenomena. Okay, so if you know this machine on the right, I'll be surprised, but it should be nice. It's a very recent archaeological discovery by archaeological discovery standards. Okay. Then we figured out a general language for describing this phenomena, and you should be familiar with the laws of motion here, and with the formula for entropy. We used machines we used this language to describe the natural phenomena. Then also about 100 years ago, we started having a computational approach to problems. Okay, so now we could we created technology that could aid us in describing this phenomenon. So computation and data science is sort of the intersection of these three fields and this Venn diagram, right? So there is computer science, which is this aspect of computation. Right? There is math and statistics that provide the theoretical foundation, and then there are specific knowledge that people might have, let's say physics or biology or chemistry or engineering, right? So the Venn diagram is nice because if you put computer science and math together, you get machine learning, which is this course. Traditional, if you put math and some other specific field, then you get traditional research. So for example, if you take math and communication together, you will get communication engineering. Software development is the intersection with your computer science and domain knowledge. So let's say if you're a physicist and you want to have a finite state simulation of some fluid dynamic systems, you will go to a computer scientist. You will ask him to teach you something, and then you produce this. And data scientist, intersection of the three fields. So by its nature, it's interdisciplinary. So it's sometimes a little bit of a meme, right? That if you work in data science, you might be working one day on neuroscience and the next day on solid state physics, right? Because in a sense, you just care about the data and the science, and the domain knowledge for you is only a context. Of course, it's a little bit of a meme. The thing is that there is a focus on data. So the way in which research is done, research is presented, results are evaluated is based on available data, right? On producing data and considering the collection of data. You're aware of the computational results that are aware to you, and you adapt to changes in the environment, right? So there is the idea that if you are a mathematician, then you live out of this world, but as a data scientist, you work on COVID-related problems when there is a COVID pandemic. Okay. So very diverse fields. So this sort of heterogeneity of the topics in data science is something that people also appreciate about the topic, right? So if you work in data science, you might be able to work in very different topics at very different times of your life. You're sort of agnostic to the data. But the potential are also so there are also many different pitfalls in data science that people are aware with. So gender bias is well known. So people use softwares for reviewing CVs. So now people also use LLMs for interviews. So if you're going to have your first job at Google next year, then you might have an LLM interviewing you. And so, for example, in the job applications, it was shown that there was a favorite view of male candidates, and this is a problem in machine learning and data science because this type of bias of the models cannot be detected by the model itself. So, if you look at deep learning model and you ask, "Oh, does this deep learning model favors male candidates versus female candidates?" This will not be written anywhere in the model. So there is no way for you of testing this than to take 1,000 application, put the 1,000 application in the model, and then reveal what is the bias. So if you were not aware of the bias ahead of time, then it would be very difficult for you to identify this bias. Another very famous case of the bias was in the law system. So there was this program that was doing there was deciding bail bonds. It's an American thing, but basically, if you go to jail, you can pay a certain amount of money to go free until the day of your trial. And there's an amount to be set, and it was shown that male bonds were much lower than Black people bonds. So now this is also so benchmarking this algorithm is a very relevant topic. And this is usually the pipeline that a data scientist will consider when approaching a problem. So first you start from a question, then you have to get the data, always get the data. So if you were an engineer or if you were a physicist, at the second level, you will have write a model. Okay, so there will be the step in which you sit down and you come up with a mathematical description of the system, which is consistent with the observations that follow some physical laws. But in the data science pipeline, the next step after having asking a question is always to obtain some data that describes the fashion that can answer the question. Then you have to explore the data. So again, you're not verifying the theory, you're not building a model. No, you have to explore the data. You have to have a statistical understanding of the problem. You have to be able to explore what are possible clusters, what are possible correlation, what are possible biases of your data. Then when this is done, you build the model. And the way in which you build the model is, again, with respect to this slide, right? So the model that you build will be the intersection of some statistical understanding, some computer science implementation, and some domain knowledge, right? So the model is, again, built in this sense. And then you have to feed the model. So you have to use the data that you collected to produce a more accurate model, and then you have to validate. So we're going to go in big depth in regarding these two topics, and then also the communicating the results is something that people in data science also strive. So presenting the data in a way which is accessible by others, creating a story behind this is also considered very relevant. So we're going to explore all the different aspects of this: data collection, data cleaning, data management, data analysis, and then prediction and statistics, and then trying to communicate the results. Very good. So theory is key machine learning concepts, clustering, supervised learning, and supervised learning, data imputation, this type of stuff. Practice, implementing machine learning models in Python, using data sets that are available online, and the impact will be solving a real-life problem using data science and evaluating the societal impact of this. So just here briefly, right? So some of these words should be clear to you. So we're going to move between regression, classification, decision trees, and neural networks. So the class also covers the basics of deep learning, right? So we're just going to move to a little bit of deep learning just in case you don't take my course next semester. And the second part of the course is the one that I will teach next semester, hopefully. And this will cover purely deep learning topics. Okay, so I'll give you some time to ask me questions. If you don't have any questions, then we update you next week. And that's it. Yeah. Any questions? Okay. So for while I wait for your questions, so consider if you want to be leader. Consider if you want to be a leader. So again, leader is just a word for us. It doesn't mean that we see you as being better than the other students, right? So we just use leader in the sense that you lead the team in the challenge. So being a leader, who should choose to be a leader, right? You should choose to be a leader if you want to challenge your organizational skills, okay? If you envision yourself of being a great communicator, right? So if you want to challenge your communication skill, you should consider being a leader, and also just to challenge yourself, right? Because I think it's a great way to, to do something, to take a role that you wouldn't take otherwise. Usually leaders go ahead and have a great experience in the course, and they meet a lot of people, and usually are very happy. I will not lie to you regarding this. Yeah. So if you let's close the class here for now. I think I talked more than I wanted to, and more than I will talk usually in any other class in the remainder of our time together. So just a few things. So if you want to convince some friends to join the class, tell them that in a short 3 or 4 weeks, you'll be able to work together, because in the second phase of the class, you will be able to form teams with your best friends. So that's a plus. See if you want to join Skype. We will post Skype. If you want to join Slack, Skype is dead already. If you want to join Slack, usually we post there and we communicate there. If you want to talk to me, my response time on Slack is usually below 30 minutes, right? I'm always there. Usually my emails are a bit more swamped. What else? Yeah, we post the recording of the class on YouTube. Gaida will make a playlist, and then she will share the playlist on E3. And then every week, if you don't want to attend class, you just look at the recording. We also posted the link to the event. I will just post the link to the event here as well. I know that you guys don't use a calendar because you guys don't need to. Just a second. Publish event. Copy link. Copy. So if we usually use Google Calendar for meetings. So this is the calendar link. So if you click here, it will go to your calendar application. I think it works both for MS Teams and Google Calendar and Apple Calendar, whatever. What else? The slides, I posted them here. We will also post them in Slack, and yeah, so they are there as well. Anything else, guys, that you want to know? Otherwise, we call it for today. Yeah, so Liang posted the Slack link. Yeah. As I said, if you want to talk to me in person about the class, about other things, I'm usually here. I see that there are some exchange students. I might need to sign some form for you, or if you need anything. Yeah, otherwise, usually I'll be here for 5 more minutes, so I will just mute my microphone. I will say hi to everybody. If you want to, I will stop the recording. So if you want to ask me something, you ask it then. Otherwise, I'll see you next week. And to the people looking at the recording, we will see each other next time. Okay, ciao, guys.